All right. So switching up into geometry. All right. The most basics of everything in geometry boil down to area, good starting area, and perimeter. We also have to understand that perimeter is called something different when you're talking about circles. Right?
Circumference.
Circumference. Yeah, circumference is the same thing as perimeter, the distance around. And those, and we'll talk about those in the middle. But as long as we understand the area and perimeter, how relative they are to so many different things. I want to take a, ooh, perfect. Look at number 10. If the area of the rectangle above is 15, what is its perimeter? Okay, that's what that says, and that's what we're going to talk about, because I find this as a common problem a lot of times too, converting from one to another. Mm-hmm. All right, so in your case, you have a rectangle, and what number's over here?
It's a 3, so
3.
it's got to be a 3 on the other side.
So there's got to be a 3 on the other side. There's a 3 over here. There's got to be a 3 right there.
Oh,
right?
Yeah.
Yeah, because in the box it's all parallel. Obviously, the sides are the same. But we know the area is what? What's that area was?
15.
15. How do we get area? What is area anyway?
Length times width.
Length times width. All right. So we got the length or the width, whichever one you want to call it, is 3. So that means 3 times something equals 15, right?
Right.
Mm-hmm.
So what's that other something?
5.
5. So we know that up here has to be a 5. Up here, down here has to be a 5.
Right.
So if I have that, then I know the perimeter. Yeah. The perimeter has to be 5 plus 5 plus 3 plus 3 equals 16. All right? Now, let's say I had to work this problem backwards now. What if I knew the perimeter, in this case, the perimeter was all right, perimeter was 20. All right. Perimeter was 20. I'm looking for the area, and I know, all I know is one of my sides is a 4. I'm looking for my area. I know one of my sides is a 4.
So it means, can I ask?
Hold on, let me get everybody.
Just wait.
Yeah,
Okay.
just a second. No, I appreciate
Okay.
it. Appreciate it. Yeah, just a quick second, everybody. Yeah, marinate a little bit.
Sorry, I'm a little bit OCD, so everything has to be.
Hey, what makes, this is about you being successful and whatever you need to do. So, you know, I'm I need to stuff familiar. Where am I from?
All right.
Oh, yeah. He's a lawyer.
That's fine.
Yeah, he's a lawyer for Kentucky Education Association. He was, he had to deal with a case this past weekend. Oh, yeah. He used to be the lawyer for JCTA. Yeah.
Alright, go on.
Move on. All right, what you getting ready to say, Twan?
So it means that since the perimeter is 20,
Mm-hmm.
I know that the other side has to be a 4.
This other side has to be a 4.
And so my two, the other two sides are
Right.
6.
Right here have to be. Now, where'd you get 6 from?
Yeah.
Because 4 plus 4 is 8.
All right, 4 plus 4 is 8.
Yep. And
Whoops. 4 plus 4 equals 8. So we know you took that
those two sides will
So-
give us 8.
20 minus 8 gives me
Give us 12.
12. So we got 12 numbers left over.
Right.
All right,
And then you can divide 12 by 2,
12 by 2.
which will give you 6.
Absolutely, because we know these two sides are going to be the same.
Right.
So if I the rest over, if I already have 8 out the way, I know this is 4, this is 4, 8 is out the way, out the picture. I got 12 left. I got to split that in half because these sides are always equal.
Right.
So exactly, half of 12 gives me that this side has to be 6 and this side has to be 6. Now let's not celebrate yet because we haven't answered the question.
Right.
What was the question?
What is the area?
What is the area? What is the area?
6.
Ah, there it is. It's 24. 6 times 4. 24. Now, it's one of them things that you got to be wary of because you're going to get, you know, if I was writing this test and I was just as sneaky as those guys doing that, then I would say I'd have A 12, I'd have B 6, I might have C as, yeah, somewhere in the career. I might do a 20 and then might put D as 24. You know, all those numbers that you've seen in your problem that you just like, oh, I seen that number. All right, cool, let me choose that. That's how they operate. So make sure, that's where, you know, back to your test taking strategies, make sure you read the problem thoroughly. And more importantly, read the last sentence of that problem thoroughly, twice. 3 times if you need to, because a lot of times we get caught up in all this math. We got to go back to the original question. The question was, what's the area? You know, so you know that's very important. We don't get lost in that stuff. Okay, cool. Leave it there, right there. I want to do another one. Let's see what you get. Let's say this time again we got area is, let's say your area is 35. Area is 35. One of your sides is 7. What's your perimeter? I'll let y'all work on that real quick. And in fact, in this one, I'm actually do a test time and strategy. We're gonna do this one in less than a minute. Now, Mia, you dropped the pencil first. What'd you get?
Area 35, perimeter 24.
All right, walk me through it. What'd you do?
I knew that side was 7, so the side up top was 7.
All right.
And then I knew 7 times 5 is 35.
Mm-hmm.
So both sides have to be 5.
Right. Both sides
Add
of
them all
5.
together, you get your perimeter.
10 plus 14, 24. All right, cool. Good. I think we're pretty solid there. I want to go on to what I say the second part of area and perimeter is called circles. Let's talk about circles. Area and perimeter with circles, also called area and, thank you, circumference. Circumference. Yeah. Some things to also keep in your mind that you should always think about when you're taking these tests is that if you have a problem that asks you about area, and you have a problem that asks you, and they give you units, centimeters, inches, miles, whatever, units, your answered area will always be square. That's one thing. That's one of the notes. Area units are always squared. Area units are always squared. Like you might have 7 meters squared. That has to be an area. So that's another thing that you look at when you look through your multiple choice and you see 7m, 8m cubed, and 8m squared. Then you've already eliminated 2 of those because there's no possible way that, hold on, I didn't put no letters.
Can't be cubed and it can't be one without.
Absolutely. So we know off top, and that's in your test taking strategy too, to eliminate the ones that you know aren't it, then that's automatically, these cannot be it. So we got to keep that in mind. That's for your circles, that's for your rectangles, that's for your triangles. So we have to look at it that way. Okay, cool. So we have that. We got area and circumference. Now, that's area right there. I'm going to erase this right quick and get down to my little area spot. Now, area for a circle. Area for a circle. The formula for that is pi radius squared. All right. Not to be confused with circumference, which is 2 pi r. Now, you can never confuse these because you know that area is always going to be the one that's squared. Right? It's the exact same letters and things. There she is, riding dirty. All right.
So one you have a 2 in the front and the other one you have a 2 on the end.
Yes, one you got the square and one you have the 2 in the front. And there are definitely ways to memorize those. It's just the same letters, just in different places. So we have that. We got the pi r squared, you got the 2 pi r. Now, the thing about these is, a lot of times in your questions that they give you, they may or may not use the pi. They may ask you to say, okay, plug in 3.14 for pi. But a lot of times they won't even care about the pi. They just want you to solve and see if you can think your way through the problem. And the key to all these problems, converting area to circumference, converting circumference to area, is finding out what that doggone radius is. What is that radius? Now look, let's take for example. Say for example, I know that the area of a circle is 25 pi. The area of a circle is 25 pi. That means they've already done the calculations for me. They've already, now, let me back up real quick. Make sure that we understand that r squared is the same as r times r. A number times itself, that variable. r squared equals r times r. All right, that's what the square means. The exponent, I should say, the exponent tells you how many times to multiply a number by itself.
Like 9, would be 3.
Right, and in this case, they already took the number times itself and got 25. So we know what that original number had to be. What was the original number? The original number was 5. Absolutely. So that means that when they started the problem, it looked like pi 5 squared. 5 times 5 gave me that 25 pi. All right, so I know from this problem, my radius is 5. I got that. I can do anything with that. Now I can go for my area and say, hey, what's my circumference? My circumference being 2 times pi times 5. All right? And for my purposes, you don't have to solve for the pi. You just multiply your big numbers, 2 times 5, 10, 10 pi. All right? 2, yeah, 5, 10, 10 pi. Other things we need to know. Let me give y'all one of these real quick. It should be a pretty quick one right here. You don't even have to do the minute thing because I think y'all will do it in 30 seconds. So, let's say same direction. Before I go back in the other direction, let's say in this case, what I have, let's say that the area is 81 pi. Then what's the circumference?
Oh, sorry.
Yeah. All right. Go ahead, Twan. What was that?
Sorry about that. I thought you was asking. I'm
No,
sorry.
you could.
So the radius is 9.
Radius has to be 9. So true. Radius is 9. Did everybody get 9 for the radius? All right, cool.
I
And
didn't write it
then,
down, but I plugged it in on the
Oh, you already just plugged it in. Mm-hmm.
so then the circumference is 2 pi, or 2 times pi times 9,
Yes.
which will give you 18 pi.
18 pi. And like I said, if they tell you that pi is 3.14, hit that in your calculator, 18 times 3.14, and your answer will be right there.
Yes.
All right. So let's go in the opposite direction now. Let's say, opposite direction means I gotta do a new page. Do you have what you need?
yeah.
Okay.
I do a lot of stuff. I keep a lot of stuff in my head.
Yeah. And I understand. So let's say this time we have a circumference. Let's say that my circumference is 22. All right. Circumference is 22 pi, I should say. That's what I should be. 22 pi. That's my circumference. So now we got to go from there and try to find our area. We haven't done that together, but I'm counting on you to do that.
Pi 3.14.
Right. Let's see. What's the radius in this problem? Remember what the formula for circumference is. It's 2 pi r. So that circumference is 2 pi r. So,
Oh, we're still using that.
yeah.
Oh, okay.
That's how you get the area. Because what's the first thing we got to find? We got to find the radius. And every single one of these problems, the most important thing is to find the radius. Now,
So
this
then
problem,
that's 10.
close, perfect,
11.
11. Because you see it? Yeah, because
22, because I was going, I gotcha.
Right.
Okay.
Because 2 times is r, 2 times whatever that is, gives me that 22. So if I know that, then that's why I was like, yeah, memorize these formulas. It's so super important. So I know that 2 times something equals 22. So 2 times r equals 22 because those pi's are a non-factor right now. So 2 times r, 2 times something, divide both sides by 2, divide both sides by 2. R equals 11. So I know my radius is 11. And now from this point, what's my formula for area? Pi radius squared.
Radius squared.
Right. So that's the same thing as pi times my radius is 11 squared. And what is 11 times 11? 120. 121 pi. You don't have to memorize that. You got good calculators for that. So that's good. So 121. So it goes backwards and forwards in this. Let me give y'all one more of these.
Hang on, let me.
Hold on,
Go
let
for
me
it.
write this down.
Do what you do. Yeah, thank you. Please feel free to slow me down because I get on a roll and I take things for granted that you know some things when I don't, when you don't. So, you know, so please let me know. Slow it down, break it down a little bit further because get what you need out of this. Get what you need. This is that time where you be super selfish as you can. Don't worry about anybody else in the group. Just, you know, like, nah, they might get it, but I don't. I really don't care. I'm gonna make sure I get it. Selfish is the key. The opposite of what we teach. Down.
Okay.
All right, cool. This part, I'm gonna do another circumference to area. We're going from circumference. Let's say my circumference is 14 pi. So now I gotta figure out what's my area. Oh, snap. 40 minutes. I thought it was 40 seconds. All right, cool. All right. Set that. All right, let's try that differently. All right, cool.
So is this a fraction or not a fraction, but like 3.5?
What'd you get as a radius?
I got 7.
7. All right. So 7's a radius, and you got pi radius squared. What are we gonna do to that 7? We're going.
No, for circumference I got the 7. Get it wrong?
Oh, you should have got the 7 as just the radius. Just the radius should have been 7, and that's because 2 pi r in this case
Equals 14.
equals 14 or
And then
14 pi. Like I said, the pi is automatically canceled. We're not worried about that. So it really becomes 2r times 14.
Right, and then you divide by
Right.
2 on both sides, which makes R7.
Right, r7.
Okay,
So
I
now
did that.
you did that. Now you got to go ahead and plug it over here into this area formula.
Oh, so then I gotta put 7 and then square it.
Yes.
which would be
49.
49. Yeah,
Right.
because 7 times 7.
Right.
Okay.
Right.
That's where I was.
49 pi, the disconnect
yeah,
right there.
Yeah. I was
Absolutely.
Like, where?
Yeah.
I was off in somewhere else.
Okay. Yeah. I'm gonna go real quick and chill right there. Take a 2-minute break real quick. I'll be right back. Circumference of 16 pi. And again, you gotta find the area. See if anybody's found a shortcut of just getting the radius already. You got the shortcut of getting the radius?
Yeah.
Oh, yeah.
You should have took over Mrs. Ice's class.
Yeah.
You should have took over that class. Because this right here,
Right.
I'm not doing it. I'm not doing it.
Yeah.
I can't wait to do this class.
Mhm. All right. You got your little 2-step problem on. If you get it down right, you really understand it's really just a 2-step thing.
Yeah, it really is.
Yeah.
It really is.
What's the first part of this step?
2 times 8
All right.
is the 16.
Half of the 16. You got your 8.
So R is
8.
8. 8 times 8 is 64.
8 squared. 64 pi.
I have to do square with circles.
Yep. And again, same thing. Problems with area on your test. Again, the units have to be squared. All right, let's get out of circles real quick, and let's go into this shape right here. Triangles. The basis of trigonometry. Got the word triangle in it. Trigonometry, which is the basis of calculus, which is everything is based off of a triangle. Slope is based off of a triangle. God, too many
All
things are
this
based
left
off.
and right angles.
Absolutely. Mm-hmm. Yep. All angles, the cube, the twos, all that.
45.
Yeah. And yeah. And then we're gonna talk about that soon. A triangle. The definition of a triangle, simply a 3-sided, figure. But I like to get a different definition of triangle. My definition of triangle is half, there we go, one of your important fractions, half of a rectangle. A triangle is half of a rectangle. I shouldn't even say rectangle, I should have just said a parallelogram. Doesn't matter, same thing. Okay, 4-sided figure. A triangle is half of a 4-sided figure. Now, I like to use the word rectangle for the specific purpose of this, a parallelogram, because what is the area of a rectangle?
The area?
The area of a rectangle. Yeah, base times height, or length times width, like we talked about earlier.
Right.
So if a triangle is half of a rectangle, what's the area of a triangle? It's 1/2 times base, or length times width, or base times height, whatever letter you want to use. So when you're thinking about the area of rectangles and triangles, triangle is something that you don't have to memorize. As long as you know that a triangle is half of a rectangle, area of a rectangle is length times width, area of a triangle is half of that. So you get your triangle, you get a triangle, you gotta identify its height. Funny shaped one like this might give you this little funny dotted line down here. This funny dotted line is called the altitude, which of course is just another name for our height. So then if I get my altitude, and I know my altitude is 6, and I know my base is 9, what's the area of this triangle? I hadn't even thought about it. I was just throwing it out there. Yeah, just throwing it out there. I definitely should have just put
So
my time
couldn't
on.
you do this stuff with, like what we did earlier with the times with the
Yeah.
area? And then divide it in half?
Absolutely. Absolutely. Length times width and then divide it in half.
Yeah, because you already have one of the,
Yeah. Length times width and divided by half. That's it. That's it. That's all you got to do. And what y'all get? 27. Absolutely. Absolutely. 6 times 9 is 54. 54 divided by 2 is 27. If you didn't want to do it that way, you could have just said half of one of these numbers and then multiply by the other number. It's all works the same. Half of 6 is what? 3. 3 times 9 is 27. Done. You know, either way you want to look at it, because multiplication is part of the, it's one of these terms that you'll have right here. They're associative. And so whether or not I take the length times width first, multiply it, and then times it by 1/2, makes no difference. I can take the half of the length first and then multiply that by the width. I make half of the width first and then multiply that by the length. So I can go in either direction. For me, it was just easier in my head just to take the half of the 6, 3, and then multiply it by 9, because I wanted to cut down on my big multiplication or division if I had to do that, you know. But that's just one of those things. All right, all right.
so the answer would have been 27
The
then.
answer would have been 27. Yep. 6 times 9 times 1/2. Yep. 27. Okay, cool. Now, speaking of triangles. Everything deals with a right triangle. Right triangle was the most important triangle, because everything runs off of that. And you know what we were talking about earlier. We were talking about Pythagorean theorem. Yay! Good times.
It ain't A squared.
Absolutely. A squared plus B squared equals C squared. And that just comes from the basic logic running through that. It'll say this side over here is called A, this side over here is called B, and this side over here has to be called C.
Mm-hmm.
Now, in what I'm saying, it doesn't matter which one of these legs you call A or B. The only thing that matters is that C is across from this little baby square right here. This little baby square lets me know that this is a right angle. All right, this is my 90-degree angle, go straight up and straight across. So the side across from that has to be C. C always has to be what is called the hypotenuse. The name of this. Hypotenuse. This is a leg, and this is the other leg. Got 2 legs on the hypotenuse. Now again, it doesn't matter which leg you call A and which leg you call B, but it is extremely important that you know that the side across from that little baby square is called the hypotenuse and is your C. All right. Now the whole theory behind this, real quick, is, let me get y'all a chance to write real quick because I'm gonna be ready to.
Yeah, I light it up.
Yeah, you know, I'm gonna continue to roll on, you know. Yeah, keep going, keep going, keep going. Should go back to my coaching days. I feel like we can ready to do push-ups now.
Yeah.
Don't make me do that. I'm gonna be able to get back up. I'll be on the floor like this. A 1, a 2. I'll lift my head. That's about it. I got it.
There we go. All right, so I'm gonna erase these words. I'm assuming that you have these words written down, just like legs. How about if you need them? You may or may not need them. Legs, hypotenuse. Okay, so that's my B right here. Now, the whole theory behind this is this. This way, the length of this side is A, just like the letter A. We don't know. Call it whatever number you want to call it. Now, if I were to create a similar side that's the same side as A, like this length is length A, this length is length A, and create a square out of this, then this whole thing is called a square. Right? A times A is A squared.
Because it equals.
Right.
Equal parts.
Equal parts. Right. Because it's a complete square. Now, if I did the same thing with B, the length of this is B, then I created a square out of this, where this side is also the length of B, and I got a whole thing, then this side is called
B squared.
B squared. Of course, by the same logic, I got this out here, I got a C, the length of this is C. Look. The length of this is C. Oops, that means that this is a C. Then of course, this is C squared. What Pythagorean theorem says is pretty simple. They say that if I had a triangle, a right triangle, I created a square out of each of its sides. If I added this A square to this B square, it'll equal C squared. So if I add both of these little baby boxes together, put them together in one big old box, it would just completely form the big box up there, C squared. It would really, you can't tell that from my drawing because my drawing sucks. Okay, but if we were to do this in
You were trying to do it what it is.
thank you. Then we would. You know, if we had some paper cutouts and we did the little triangles and we actually cut those boxes out and did something real, it would 100% perfectly fit on top of that. You have to cut it up a little bit, but it would fit the same area. Right? So that's the whole basis behind there. So when we use it in actual practice, we got a regular triangle. Let's say I have, let me do my favorite triangle. Are we done writing this triangle?
Mm-hmm.
Okay, cool. Let me get rid of this. Move triangle. No, not triangle. Move these little baby boxes. Okay, keep the triangle, move the boxes. Oh, well, skip it. All right, cool. Here we go. So, put it in practice. If I have 6 over here, and I got 8 over here, then I need to know what do I have over there. And in this little obstacle, what we're doing, I'm going to title this one A, I'm going to title this one B, and I'm still going to use this one as C. Alright, again, C has to be across from the little baby box. A squared, 6 squared, B squared, 8 squared equals C squared. Going through the process, 6 squared is the same as 6 times 6, which is 36. 8 squared is the same as 8 times 8, which is 64. And that equals C squared. Simple addition right here. 36 plus 64 gives me a good 100. And 100 equals C squared, and we're almost done. Last part is the question wants to know what is C. It doesn't want to know what C squared is. It wants to know what C is.
So you have to divide it.
Almost. Close. That's a good way of thinking. But you do know that it is, because dividing implies that you understand that it has to be shrunk. And it does
So
have to
then
be
it's
shrunk.
actually 10.
Ooh, how'd you get that?
Because 100 is squared and it's 10 times 10.
Ah.
So to
That's
break
it.
it down to the square, you have to bring it down to its natural form, which is 10.
And then another way to say that is, in order to get rid of the square, you have to do the square root.
Square root, yeah.
Yes, that's what you defined it perfectly. You explained it great. So yes, so C squared has to be a number times itself, which equals 100. Square root of 100, and that's the thing. Square and square roots are opposites. Opposites get rid of each other, and you'll find that all the time, even in your linear equations, when you have to subtract 5 from both sides or divide from, because if you have a problem that begins with a plus, you got to get rid of it with a minus. Plus and minus are opposites. They cancel each other. Multiplication and divisions are opposite. They cancel each other. Square and square roots are opposite. They cancel each other. All right. So yeah, like you said, 10 equals C. All right. That's 10 equals C. One thing. Let me get another one real quick before I want to move on to the next concept. Let me get this triangle right here. I noticed I didn't put A and B up there because they don't matter. This is definitely what I should put back on. Train myself better. All right. How you doing over there, Emma?
It's 5C.
Ah, what'd you get? Of course. 5. Yep. There we go. All right. So yeah, like you said, 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals C squared. Square root should give you C equals 5. And that's exactly right. All right? Okay. Now,
I could do it in my head, but I'm like, I need to write this out, otherwise I'll forget.
absolutely.
Visual.
Yeah, I'm very visual, and I'm like, better write this down, so that way if I'm at home, I'm looking at it.
All right. This is one of those. This is the most common triangle you will see. The 3, 4, 5 triangle.
I saw it a lot
Right.
when I took it.
Yeah.
And I
You'll
think
see.
did you see that on some of my scores
On
when
the
I sent it in?
geometry score or
Yeah.
yeah.
It was low because I could not remember the formulas. I'm gonna be honest.
That's it.
I did not
Yeah.
look at the formulas.
Yeah.
So
It is, and it's all about those formulas. And like I said, it's once you know the formula, you're just applying the algebra. Because it's crazy because a lot of people most people score about average on the algebra. Like algebra's in tune with most other people who take it in, but then that geometry, poof, drops real down. And then they get confused on what exactly that statistic is, and sometimes that's a shaky little score too. But like I said, usually algebra and the numbers and operations are usually all right, and this is the other two. But we just got to look at it. Once you memorize the formulas, geometry really just becomes algebra, and it's the same. But we got to look at it that way. But like I said, they see these triangles all the time. They're 3, 4, 5 triangles. They're called 3, 4, 5 triangles because anytime you see a 3 and a 4 on a right angle, you always know the last one's going to be 5. You may not see it in this form. You may see it. Whoops.
So you didn't have to go through those steps. You could just.
Exactly. You didn't have to go through those steps on this one.
Yeah.
So you may see it in this form. You may see it as 6, 8. What's this other one going to be?
it would be 6, 8, 9. 9.
Now, what did you say before?
10.
10.
5 times 2
Yeah. 3 times 2, 4 times 2, 5 times 2.
Oh, okay.
So
I see what you're saying.
this is the exact same
It like
thing. as
doubles up
3, 4.
basically.
Exactly. And they
Okay.
will take this. They will take triangles that look just like this that are multiples of 3, 4, 5 and give them to you. But you're going to do Pythagorean theorem when you don't really have to. Now, I can give you this one, and I know this one is not the color I wanted. There we go. All right. And so now this one, I might have 15, 12. Now, what's that last one?
Oh, 4.
Didn't see.
That one's 5. So
Oh,
that
we're
one
actually
has
getting-
so 9.
9. I was telling that 3, 4, 5 is one of the most common triangles you see. And anytime you see a right triangle with a 3 and a 4, the other side is always 5.
Gotcha.
But then not only do you want, I was telling you might not only see it in this form, you may see it in this form, which is basically this triangle double.
And that one's triple.
And that one's triple, right?
15. Yeah.
Exactly. You'll see it in that form. So if you see a 6 and an 8, you know it's a 3, 4, 5, and you got to think of, I might be able to go down. It might help you out a little bit in order to solve the problem. You may not have to go through Pythagorean theorem all the time, especially if they give you this special triangle. And I tell you, if you don't see a 3, 4, 5 triangle, I don't know what the test is doing. But yeah, because they always show up, and that, Pythagorean theorem where you're not looking for the hypotenuse, and this time you're looking for a leg. So in this case, let's say I got a who knows? I don't care about decimals. We'll get a decimal this time. All right, fine. All right. So let me just use these two right here. All right. We'll use
So you
these
don't
two.
know.
Right. So I'm gonna let y'all work on this real quick. We haven't talked about this type of it, but